I don't want to get you bogged down with a lot of technicals here, but this is the background work that you do it one time. Once you do it, you just get an order, you feed in your parameters, boom, your assemblies are ready. You can even build the output saying that, hey, I want to create an output in step format so that I can send it to my prospect so that he can confirm this is what he wants. A simple pack and go will work with it just the way you want to send some files. All this intelligence about the rules, the expressions, and the whole package resides in the part file. So you're not maintaining 5 different things so that you can manage this. Once you design this, once you design a window, which is, I'm just going to take Pele example, and you know exactly what it is, and you know that this is going to repeat. This is one-time exercise you do, and then you process it just like that. So this is a very powerful product configurator functionality that is introduced as an add-on in Solid Edge 2022. Okay.
Super, thanks, Prashant. Yeah, so you saw lots of stuff whizzing by there. So, when you start and you want to design all the configurations of your product, yes, there's that setup. You have to educate the system on when I have this conveyor and it's this long, it needs 2 supports underneath. You saw that. And it has this many rollers if it's this long. Or if it's a little bit shorter, I just have 1 support center. Well, there's a set of rules you have to define for it to tell it that. And when it's this long, do this. When it's that long, do that. Functions that you can choose from and so on. But once that's done, then your users just get the dialogue that says, how long do you want it? How wide do you want it? Click go, and it builds the entire product for them. So it's upfront investment, but really awesome back-end automation. Okay, so the next big announcement here is that 2.5-axis milling, amazing 2.5-axis milling, is now available free with Solid Edge if you're on maintenance. And so those of you who don't know the whole history of the company, I mean, obviously we're part of Siemens now. But more or less, the folks that are part of Siemens now invented manufacturing by NC programming back in the 60s and 70s. That's how long this technology has been around in our company. So the best, most sophisticated algorithms in the industry in NX CAM, which is now Solid Edge CAM Pro. And that's now available to everybody in this room for 2.5-axis machining as long as you're on maintenance. So let's take a peek at that.
So I know 90% of the CAM CNC programming is at 2.5-axis and 3-axis. So this is going to be a gift to you guys. Anybody who has Solid Edge now has 2.5-axis milling. So let's pick up this bracket, metal bracket that connects those things, and we want to machine them. So you'll see now we are going to get it, create a fixture for it. We're going to create a base plate with a sacrificial plate. On top of it, we are going to mount it. We are going to put it into two stages. You'll see we are now going to build an assembly that will go as a fixture on Solid Edge. So you have a base plate. You have a few holes that we want to machine with 2.5-axis. We are going to mount this in a specific way. So we are going to use some dowels to locate the blank first, and we are going to put the drills that are actually going to be used as holders for the future. So this is number 1. So you have clamps and fixtures already designed, and the stage 2 is what you see on the right side. So you're going to use this into now 2.5, send it into 2.5-axis CAM Pro, which is part of your Solid Edge now. So once you send it, it is going to take you to 2.5-axis machining, and then you are going to do all the good stuff that you get it through NX CAM Pro machining features. So adaptive milling comes along with 2.5-axis. So we are going to do roughing of the pocket. We are going to do spot drilling for that left side fixture, and then we are going to move on. All the good stuff you can visualize, all that comes along with it. So you can visualize the tool path, you can configure the tools, you can design the holder, you can check for collisions, all those good stuff. You get with the library of the tools that you can select it from, and so on and so forth. So, and then you go, you can actually, it's now doing the spot drilling program. Once you're done with that, you move on. You now are going to move to the right side, which is the second stage of the same part. Now we have the pocket that's already milled. So that pocket is being used to clamp, and now we are going to run the outer contour of the component. So all this is 2.5 axis. It's nothing great about it. It comes with the post hub, so you have access to lots of post processors. You can build your own post processor with the generic post processor that you get. But all this is part of the solid edge now. So 2.5 axis, that's a big thing. That's a big thing. As I said, 90% of the machining that happens in 2.5 axis and 3 axis. So this is beautiful.
Thank you, Sean. Yeah, so big news there, and I think, again, the summary point from me is it's best in the business. It's not like you're getting a little cam teaser. It's not like you're getting some cam that kind of works. You're getting best cam in the business with solid. Okay, next up is Accelerator Share, and Prashant's going to have a session on this later today, so I'm not going to go into too much detail in here, but it helps you to collaborate with your colleagues, customers, and suppliers. And it helps you do it in a really easy, lightweight way where they don't have to go buy a bunch of products, they don't have to have special hardware, they don't have to do anything but exist. So it's next generation, cloud-based collaboration. So you can easily say, I want to share this design with so-and-so. I want to share it with view and markup privileges only. I want to share it with download privileges. Works on any device. You can use it on your iPhone, you can use it on your Android device, you can use it on your iPad, you can use it on your Windows device. And it requires no IT infrastructure. So I know a lot of the folks who come to this are maybe the IT manager as well, or the CAD manager or whatever, and you're forever configuring things and setting up things. There's nothing to do here but log in and that's it. So we'll hear more about that from Prashant a little bit later. Next great tool in Solid Edge 2022 is dynamic visualization. The ability to be able to tell what parts are a certain material, be able to tell what parts are in work, whatever you might want to use as your criteria, but be able to visualize that dynamically.
So let's look at dynamic visualization. The assemblies are getting bigger, the number of components are getting complex, it has got different properties. So here what you're doing is you're now opening an assembly in the Team Center. Now you load the assembly. I want to know what is made of aluminum and what is made of plastic. So I really want a quick visualization to separate them out. So we are going to build, you go to inspect, you have dynamic visualization, you build a table. Now you bring in the columns that you want to filter on. So you want material properties, you want who created it, you want who released it, you want when was this created. So all those properties that you already have captured on the part, now you are going to build it in the table. Now that table is now going to be used as your filter. So as you see in the table, you just click on here. I want to look at all the parts that are made out of copper, and this is what the report you will get. Visually, you can actually now separate out and work on it as for example, what parts are work in progress, what parts are made by Pat, what parts are ready for machining, all those things, those filters that it's actually reading those properties from the files and making it easy for you. So it's a quick example here to follow is using 3D Find It. Here we are trying to grab the button from 3D Find It and insert into a solid edge assembly. Remember, there are 3 other buttons that already exist in the Team Center, so it's going to find out and assign those part numbers to that button. So just a few things that you see up there. Again, all that you saw in Team Center also can be done in built-in data management. So you saw what we have done about the dynamic visualization. And you don't have to think that it is only can be done in Teamcenter. You can do it using the design manager within the built-in data manager. So you build the same thing. You have the properties. You use the file properties. In Teamcenter, you use the attributes, and that's how you get it. So simply, in this example, it's just filtering out what are the stainless steel parts, and it finds out that back handle is still not made out of stainless steel. It's defined as aluminum, and sends it back to the designer saying that please go change it. And then the designer changes it, comes back. Now the filter is applied. It shows up in the right color. So that's very useful functionality, in my opinion, for the designer.
All right, super. So I think I'm always amazed when we release a feature and then we let you guys add it, what you do with it. So this is one of those features where I feel like we're going to find users using it in a lot of different ways to provide value to your company. And I look forward to hearing how you're using dynamic visualization in the future. Next up is solid edge simulation, and like many of these things, it goes by pretty fast. So I'm going to highlight to you one thing that it'll go by pretty fast in the video, and that is some remeshing technology that we put in solid edge in 2022. I spoke to you earlier about how Siemens has acquired a bunch of companies, right, 10 billion euro worth of companies. One of those companies we acquired is called CD Adapco. CD Adapco does amazing fluid analysis, very complex stuff like explosions and things like that. Well, they had some technology to be able to mesh a mesh, and it's going to turn out to be super important because what you get in are often poorly behaved meshes. It could be that you got in something from reverse engineering. That's not a good mesh to use for finite element analysis. You got it in from generative design, you got an STL file, you got all sorts of places you might get poorly behaved meshes from. And again, you're like, what am I going to do with that? I can't use that for FEA. With this technology, you can remesh it with a perfect mesh that can now be used for FEA. So, like I said, it goes by pretty fast there, but look for that. It's called body mesher, which I'm not exactly the best term to describe what I just described. Look for body mesher if you're doing FEA. It's amazing new technology. We'll look at some of the other pieces here as well.
All right, it's going to go very fast because it's going to look at. It's going to pick up the cylinder where we are going to do a simulation for hydrostatic simulation. So it's become very easy for us. What do we have to do is just now define the body that you are going to analyze for hydrostatic simulation. Define the fluid, select the faces, select what height you are going to fill it in. In this case, you're selecting the inside faces of that tank. We selected that faces, and this is what is going to show. You're going to apply hydrostatic pressure with the fluid levels in it, and simply goes solve it. That's all what you're asking is to do. And if you go and solve it, remember we didn't mesh it. We are going to use body mesh that Dan mentioned here. So it's very powerful. It's going to do a body meshing for the surfaces that you selected, and then as like any other simulation, you can see the results. You can publish the results or whatever you want to do. So very powerful hydrostatic simulation capabilities that you will see. It's going to show you all kinds of animations and different type of results that you can fetch in. I think there's a couple of other new types of simulation results that we have introduced in 2022. So another thing that Dan probably didn't mention it, but it's beam meshing. So you select the fabricated elements, and now you want to do a beam meshing on it. This has now become very easy. Connecting those beams, because the elements are going to be at the center, is they are automatically going to connect it. Now you subject the loads, you subject the constraints and boundary conditions, and you apply and solve it, as simple as that. So lots of good things that you see. Body meshing, you see the beam meshing, and you will soon see something which is very easy also. So you're doing the simulation, structural simulation on a beam structure, simply doing the beam meshing. So Dan mentioned about something which is very tricky when you are applying a mesh to a mesh body. So this is the mesh body. You picked up a key, which is a reverse engineered key, and this is a reverse engineered mesh body. You're meshing that mesh body. So this is the tricky thing, but this is what that Dan was mentioning, is the technology that we have acquired is now going to do it very well. So simply, these are internal, advanced, patented technologies that we are bringing in the solid edge.
Super. So yeah, lots to see there very quickly. Hydrostatic pressure obviously saves you a bunch of time, because obviously the pressure at the bottom of the tank is different from the pressure at the top of the tank. Doing all that manually can be a real pain. Obviously built in now. In the beam meshing, we've obviously had the ability to do beams and solving beams for a long time, but all the auto connectivity stuff is really quite excellent. And then the mesh of a mesh is honestly unique in the industry. Nobody else can do that, and very proud to offer that to you guys. All right, and the last area I want to cover is Center Flowmaster. So again, this is something where we can take advanced technologies in the portfolio and bring them to our solid edge user base. This is a different kind of flow. Some of you may be familiar with Flow EFD. Flow EFD is a product in the solid edge portfolio. It allows you to do fluid flow analysis, typically sort of free body fluid flow analysis, like the air flowing around a car, or have a circuit board and I need to do a cooling analysis. That's Flow EFD. This is a different kind of analysis for if you're doing any type of piping systems. So if you have piping systems, you have pressure drop, I put something a certain pressure here, what's the pressure drop, how do I get the right pressure at the other area? That's what Flowmaster does, and it's now integrated into Solid Edge.
So a couple of versions ago, we introduced the PNID design in Solid Edge. So there's a lot of intelligence now already in Solid Edge, looking at the piping and routing. So now what you see here is actually now those pipes and entities that we have built, we are now going to subject to the flow. So the flow parameters that we see, that assembly that you have built with PNID and piping design in Solid Edge, now we can send them in the flow analysis. That flow analysis actually is being done with a product called a Center Flowmaster. So what it is doing is exporting those solid edge pipes into 1D geometry, and actually are listing it, extracting it, and exporting it into Center Flowmaster. So once you got it out of the solid edge, now that assembly that you still can see it, but it's now in the forms of lines and elements that the Flowmaster can understand. So here we are actually analyzing a big system, but we are really want to see a subsystem of it. So what you see is stick diagrams, right? Those are the pipes and valves and things that actually are in that piping system. So we want to actually look at that subsystem that connects those pipes. So you extract that subsystem, and you now are going to apply, just like any other simulation. Here you are going to apply pressure points and pulse points. The compressors have pulse parameters. So you have the subsystem of pipes, and I'm not the big expert, but this seems like this subsystem you're applying two ends the pressure system, and now you're doing a static analysis. Now it's not it's a static pressure. The fluid inside is air, so that's how we are doing it. And now you can see the pressure pattern along the piping system, the subsystem of the pipe. And this can go entire system altogether, or you can just say, I want to see the critical part of it because it's connected to the compressor, which has got a time pulse attached to it. So what's going to be my failure analysis, right? What kind of pressures is it going to subject? So here you can clearly see that the left side of the piping system is actually subjected to the higher pressure. So it's a very intelligent, fluid flow type of analysis that you can do. with Solid Edge Flowmaster. So this is right there in Solid Edge 2022.
All right, so not an area of expertise for me either, but it looks pretty darn cool. And I'm sure if it's an area that you guys need, it'll be great. So, as I said, we've had 2022, well, it's out now, and many of you have downloaded and are using it. But we also had it in beta for a couple months, and so folks like Karsten and Boca, you know, everybody's saying there's just so much in there. And we've only been able to kind of scratch the surface with you here today, but you'll see a lot more later today and this afternoon. I invite you, though, also to do more. A lot of people come to these things and learn about the new stuff and then go home and do exactly what they used to do. And I'd say take some time to learn the new features. You're going to find they're going to save your company a lot of money. If you want to learn more about Solid Edge 2022, obviously you're going to learn a lot of it here, but you can go on at Siemens.com, Solid Edge 2022. It's a nice, easy URL to remember to learn more about all the different features there. And then I also invite you to get involved. I know this is a semi-involved group, right? You took the time to come out this morning, so that's awesome. But also I encourage you to join the community and forum and make use of it, or provide your expertise, right? The community forum is really a place where we, instead of once a year, we daily talk about things. You will find newbies come in there and say, how do I do X, Y, or Z? And hopefully someone in this room will answer their question. Typically questions get answered in a half hour or an hour or something. My team's in there. So I would suggest go in there, provide your expertise, or maybe that every once in a while you get stumped on something. There's a lot of great stuff in there to learn and contribute, and just become part of the community. So Solid Edge 2022, Engineer to Grow Your Business. We're going to learn a lot more about that today, no matter what your company does, whether it's automatic bartenders, anyone, or Innovates or other companies in the room. Lots of different applications and lots to learn. Engineer to Grow Your Business. We're actually almost exactly on time, which is just shocking to me. So we do have time for a question or two if we have any questions from the floor. Yeah.
When you do SolidWorks integrations into Solid Edge, previous versions it didn't behave with them. So we've tried to import a SolidWorks part into Solid Edge and it says can't recognize. The question is, on the metadata properties, being aligned, our big deal is you've got to get clean bill of materials, and the two don't play well together when it comes to the metadata properties being aligned.
Okay.
Being done in that category.
So the question for folks in the back of the room was about bringing in SolidWorks data, and particularly the metadata properties. The answer is I can't answer your specific question, but I'd be happy to talk with you offline with Prolim and so on, and we can get an answer to your question. What I can tell you is this: by far, the largest number of folks coming to Solid Edge are coming from SolidWorks. They're doing a lot of work on making that transition comfortable. So it's somewhat likely that we're working in that area, but I can't say for sure. So let's get offline and we'll find out. I mean, if you have an IR, I can look it up, I can see what happened to it. Is it lost to the system? Are we working on it? Whatever. So let's talk to Prolim, make sure an IR is logged, I can run it down with my team.